Today, let's talk about player customization system. You may want player to be able to customize their outfit, appearance, weapon, and so on in your game. We will take weapon as example in this video tutorial. You should be about to design a player customization system for outfit or any other customizable things. First, let's see what we need in this player customization system. You should be able to change weapon. After a player change his weapon, the system should remember which weapon he selected so that the player doesn't need to select again. And we need to sync the weapon between online and offline lobby and also the MMO system. In the MMO system, we should show the weapon are currently equipped by the player and change it if the player change it. After determining the feature we need in the player customization system, we can start designing its implementation. First, to change the weapon, we design a UI to change it. To remember the weapon for the next login, we can use a weapon ID and save the mapping between weapon ID and weapon info as the in-game data table or constant map or variable. And then save the weapon ID as a user attribute in the Cognito user pool. When a player logging back, we can retrieve the weapon ID from the Cognito user pool and use it as a query to the in-game data table or constant map variable to get the weapon infos. To sync the weapon between online and offline lobby, we divide it into two cases: sync weapon when we enter online lobby and sync weapon in the online lobby. Because we want to get the weapon info once we enter the game on the server side, so that the server side can know which weapon should be equipped for the player character. We add the weapon ID to the player data when we start a game session placement and add the player session ID as the option in the open level node. The server side will be able to get the player session ID from the net connection request URL directly before the player enters the server and spawn a player character with the player session ID for the player instead of using RPC function after the player enters the server. Then we use the player session ID to retrieve the weapon ID from the gamelift server and retrieve the weapon info from the in-game data table or constant map variable by the weapon ID. But there is one problem when we use this way. Unreal Engine doesn't allow us to get net connection request URL from the player controller in Blueprint by default. So we have to add some CPP code to create our custom player controller class for the Blueprint. If the player change his weapon in the online lobby, then we use RPC function to sync the weapon info to the server side and to all clients. And in order to sync the weapon info to MMO system, we include a weapon ID as well when we update your location info after player changes his weapon. In the MMO system, we will also get the weapon ID when we get player list and use the weapon ID to retrieve the weapon info from the in-game data table or the constant map variable, and use replicated variable to sync weapon info. When the MMO player changes his weapon, we will also retrieve the weapon ID with location info, and then we can use RPC function to multicast the weapon info from the server to all clients after we retrieve the weapon info from the in-game data table or constant map variable. In order to upload our project to the AWS, we will need to compile our project as Linux server executable. We will show it both in Mac and Windows. For Mac, you will need to go to the project folder and type those commands in the terminal, like bash /initiate build linux.sh, and we will just wait till it finished. And in Windows, the step is pretty straightforward and easy. So you just go to the editor and go to platforms Linux ARM 64, pick development and the
server and package project, and that's it.
After compiling the Linux ARM64 server, we compress the compiled files along with the file required by the server into the zip file, and then upload it to the S3 bucket we created in the first video. We can create AWS CloudFormation stack while we are uploading it using the AWS CloudFormation template we provided with the example project. We can set a position update interval here to convert a WebSocket MMO system to the real time. You can change other parameter based on your use cases. After the uploading finished, we get object version from S3 bucket and place it into the game server build object version in the AWS CloudFormation stack. Let's continue after it finishes. After the AWS CloudFormation stack is finished creating, we can set the necessary variables in the game instance based on the CloudFormation stack output. We have added the quick link to the AWS Cognito user pool client so that we could get client secret easier. Let's check the result. We can see the player equipped a shotgun at the beginning. And now let's change it to a pistol. Now it's a pistol. Let's see which weapon will the player character equipped after login again. We can see it's pistol. Let's test online lobby. Let's select a shotgun for test user 1. Then enter online lobby. We can see that test user 1 equipped a shotgun once he entered the online lobby. Let's check the MMO system. Let's switch to the pistol for test user 2. We can see that the MMO AI player of test user 1 on the test user 2 client is equipped with a shotgun, and MMO AI player for the of the test user 2 on the test user 1 client is equipped with a pistol. Let's add the test user 2 as a friend and invite him to the online lobby on test user 1 client. We can see that the player character of test user 2 on both client is equipped the pistol once he joins. And test user 1 is equipped the shotgun on both sides as well. Let's try change weapon for test user 2. Let's change it to a rifle. Test user 2's player character is equipped a rifle now on both clients. That's all. Thank you guys for watching.